You just realized your business needed to hire someone yesterday. How can you find amazing candidates fast? Easy. Just use Indeed. Stop struggling to get your job post seen on other job sites. With Indeed sponsored jobs, your post jumps to the top of the page for your relevant candidates, so you can reach the people you want faster. According to Indeed data, sponsored jobs posted directly on Indeed have 45% more applications than non-sponsored jobs. Don't wait any longer. Speed up your hiring right now with Indeed. And listeners of this show will get a $75 sponsored job credit to get your jobs more visibility at Indeed.com/PODKATZ12. Just go to Indeed.com/PODKATZ12 right now and support our show by saying you heard about Indeed on this podcast. Terms and conditions apply. Hiring? Indeed is all you need.
Right now, get up to a $15 gift card after rebate when you purchase select Superstart batteries exclusively at O'Reilly Auto Parts.
O'Reilly Auto Parts.
Welcome to Bedtime Astronomy. Explore the wonders of the cosmos with our soothing Bedtime Astronomy podcast. Each episode offers a gentle journey through the stars, planets, and beyond, perfect for unwinding after a long day. Let's travel through the mysteries of the universe as you drift off into a peaceful slumber under the night sky. Cosmic Neutrino Breakthrough, Europa Clipper, Navigating the Stars, Heliospheric Particle Trends Unveiled. Cosmic Neutrino Breakthrough. An extraordinary cosmic occurrence was recorded on February 13, 2023, marking a breakthrough in our understanding of the high-energy universe. Deep beneath the surface of the Mediterranean Sea, the ARCA detector, an integral part of the kilometer-cube neutrino telescope known as KM3-NET, captured an event that is consistent with a neutrino possessing an estimated energy of roughly 220 PeV. To put this in perspective, the energy involved is equivalent to about 220 million billion electron volts, making it the most energetic neutrino event ever observed. This single event, designated KM3-230213A, not only stands as a record in terms of energy but also provides the first tangible evidence that neutrinos of such extraordinary energies are produced in the universe. The detection was achieved by meticulously analyzing data from a vast network of optical sensors submerged deep in the ocean, where the natural environment of seawater acts as a medium for neutrino interactions. In this instance, a solitary muon, produced by the interaction of the high-energy neutrino near the detector, traversed the entire detection array. This muon left behind signals in more than one-third of the active sensors within the detector, and its steep trajectory combined with its immense energy strongly indicates that it was created by a cosmic neutrino interacting in the vicinity of the instrument. The observation represents a monumental step forward in neutrino astronomy, opening a new window to study cosmic phenomena that accelerate particles to mind-boggling energies. This discovery was not the result of a single individual's work but rather the outcome of extensive, collaborative efforts among an international group of scientists, engineers, and technicians involved in the KM3-NET project. Their collective endeavor, which spanned rigorous data analysis and the refinement of complex detection methods, culminated in the detailed documentation of the event in a scientific publication in Nature. The detection has significant implications for astrophysics, as it suggests that extreme astrophysical events, such as those associated with the violent processes surrounding supermassive black holes, supernova explosions, and gamma-ray bursts, could be responsible for producing these ultra-high-energy neutrinos. These cosmic accelerators are known to generate streams of energetic particles known as cosmic rays, and when these cosmic rays interact with matter or ambient photons, neutrinos and other secondary particles are produced. In some cases, Even interactions with the pervasive cosmic microwave background radiation during the long journey across the universe may yield highly energetic neutrinos, sometimes referred to as cosmogenic neutrinos. Neutrinos themselves are among the most elusive particles known to science. With almost negligible mass and no electric charge, they interact extremely weakly with matter, making their detection a formidable challenge. Despite being the second most abundant particles in the universe after photons, their ghostly nature requires the construction of massive detectors like KM3-NET to capture even a single interaction. The telescope, currently under construction, is designed with two main components: ARCA, which focuses on studying high-energy neutrinos from cosmic sources, and ORCA, which is optimized for investigating the fundamental properties of neutrinos, such as oscillations. The ARCA detector is located at an approximate depth of 3,450 meters, some 80 kilometers off the coast of Sicily, and utilizes a vast array of detection units anchored to the seabed. Each of these towering structures is equipped with multiple digital optical modules containing numerous photomultipliers that capture the faint Cherenkov light, a blue glow emitted when ultra-relativistic particles travel faster than the speed of light in water, produced by secondary particles from neutrino interactions. The achievement of recording such a high-energy event using only a fraction of the final planned configuration of KM3-NET is a testament to the detector's design and the technological prowess behind it. The data collected are transmitted via submarine cables to shore-based facilities, where advanced calibration and reconstruction algorithms work in tandem to determine the trajectory and energy of the detected particles with great precision. This level of detail not only enables researchers to infer the likely origin of the neutrino but also paves the way for future studies aimed at pinpointing the sources of such extreme cosmic events. Although the true origin of this particular neutrino remains uncertain, with possibilities ranging from a direct emission by a powerful cosmic accelerator to it being a cosmogenic neutrino produced by interactions with cosmic background photons, the observation itself is a critical first step toward a clearer understanding of the high-energy universe. The scientific collaboration behind KM3-NET brings together a diverse team of over 360 experts, including scientists, engineers, technicians, and students from 68 institutions spanning 21 countries. This global network of talent is unified by a common goal: to probe the universe at energy scales that were previously inaccessible, thereby ushering in a new era in neutrino astronomy. With ongoing efforts to expand the detector and enhance its sensitivity, future observations are expected to yield more such events, gradually building a comprehensive picture of how and where these ultra-high-energy neutrinos are generated. The expansion of KM3-NET, once completed, will result in a detector that occupies a volume exceeding 1 cubic kilometer, a scale necessary to capture the rare interactions of neutrinos and to unlock the secrets of the cosmos. In summary, this record-breaking neutrino event is a milestone in both particle physics and astrophysics. It represents a successful melding of innovative technology, precise calibration, and international scientific cooperation, all of which are essential for advancing our understanding of the universe. The detection of such an extraordinarily energetic neutrino not only challenges our existing models of particle acceleration in cosmic environments but also offers a glimpse into the profound processes that govern the most extreme phenomena in the cosmos. As researchers continue to refine detection methods and expand the capabilities of instruments like KM3-NET, the future of neutrino astronomy looks set to reveal even deeper insights into the fundamental workings of the universe. Europa Clipper, navigating the stars. 3 months after launching from the Kennedy Space Center in Florida, the Europa Clipper is continuing its long journey through space, with its sights set on a rendezvous with Jupiter's orbit in 2030. The spacecraft, destined to capture unprecedented close-up images of the icy moon Europa, still has roughly 1.6 billion miles to travel before it reaches its final destination. During this extended voyage, the orbiter is already fulfilling important functions that will aid in both its scientific and navigational objectives. As the spacecraft makes its way through the vast interplanetary distances between Earth and Jupiter, it is not only focused on its primary mission of studying Europa but is also busy orienting itself with the help of a set of specialized cameras known as star trackers. These instruments, distinct from the main science cameras designed for imaging the moon's surface, serve an essential navigational role. They observe the stars, using the fixed positions of distant celestial objects as reference points to determine the exact orientation of the spacecraft. This information is critical, not only for ensuring that the telecommunications antennas remain properly aligned with Earth for smooth data transmission, but also for guiding the science instruments so that they are correctly pointed when the time comes to capture the intricate details of Europa's surface. In early December, the star trackers transmitted the first set of images captured by Europa Clipper, marking a significant milestone in the spacecraft's journey. The images, formed by a combination of 3 individual shots, reveal a sparse but precise starfield composed of faint pinpricks of light from stars located between 150 and 300 light-years away. Although this starfield represents only a tiny fraction of the entire celestial sphere visible from the spacecraft, mapping even this narrow slice of the sky provides crucial data. By analyzing the positions of the stars, engineers are able to accurately determine the spacecraft's orientation in space, ensuring that every component, from the science instruments to the communications systems, is aligned correctly. Among the stars captured in these early images are the 4 brightest members of a familiar constellation, historically associated with ancient mythology and revered for its symbolic significance. These stellar markers play an important role in the spacecraft's orientation system, enabling it to maintain a consistent attitude as it journeys toward Jupiter. The successful
You just realized your business needed to hire someone yesterday. How can you find amazing candidates fast? Easy. Just use Indeed. Stop struggling to get your job post seen on other job sites. With Indeed sponsored jobs, your post jumps to the top of the page for your relevant candidates, so you can reach the people you want faster. According to Indeed data, sponsored jobs posted directly on Indeed have 45% more applications than non-sponsored jobs. Don't wait any longer. Speed up your hiring right now with Indeed. And listeners of this show will get a $75 sponsored job credit to get your jobs more visibility at Indeed.com/PODKATZ12. Just go to Indeed.com/PODKATZ12 right now and support our show by saying you heard about Indeed on this podcast. Terms and conditions apply. Hiring? Indeed is all you need.
Operation of the star trackers is also an important part of the overall hardware checkout process that has been underway since the spacecraft's launch aboard a Falcon Heavy rocket. This period of rigorous testing and validation ensures that all systems, including delicate optical components and their associated electronics, have survived the harsh conditions of launch and are now functioning as expected in the deep space environment. The orientation provided by the star trackers is distinct from, but complementary to, the navigation operations that guide the overall trajectory of the spacecraft. While navigation determines the path through space, the precise attitude control provided by the star trackers is vital for both telecommunications and the accurate pointing of scientific instruments. One of these instruments, a sophisticated imaging system designed specifically for Europa, will eventually be used to capture detailed photographs of the moon's fractured and rugged surface. Although this imaging system currently remains protected by its covers during the initial phase of the journey, the successful calibration of the star trackers assures that, when the time comes, the instruments will be perfectly aligned to document the mysterious ridges, valleys, and fractures that characterize Europa. Europa Clipper is equipped with a comprehensive suite of scientific instruments intended to unlock the secrets of the icy moon, including equipment for gravity science investigations and a variety of sensors that will collect data during the planned 49 close flybys. These instruments are designed not only to map Europa's surface in high resolution but also to investigate whether the internal ocean beneath the ice possesses the conditions necessary to support life. The careful orchestration of this payload highlights the mission's dual focus on both exploration and the search for signs of habitability beyond Earth. At the time of writing, the spacecraft is approximately 53 million miles from Earth, hurtling along at a speed of about 17 miles per second relative to the Sun. This remarkable velocity is a reminder of the immense energy and precise planning required for interplanetary travel. In the near future, the spacecraft is scheduled to perform a maneuver that will bring it into a close pass of Mars. This flyby, planned for March 1st, will involve steering the spacecraft into a looping trajectory around the red planet, using Mars' gravitational pull to increase its speed and further refine its course on the long journey toward Jupiter. The Europa Clipper mission, with its advanced suite of instruments and navigational systems, is a striking example of modern space exploration. By leveraging technologies such as star trackers for precise orientation and a robust series of onboard sensors to capture critical scientific data, the mission represents a significant step forward in our ability to explore the solar system. Every system, from the intricate optical devices to the complex communication networks, is working in harmony to ensure that, when Europa finally comes into view, the spacecraft will be ready to document every detail of its enigmatic surface. This mission is not just a journey through space but a carefully choreographed series of scientific and engineering feats designed to expand our understanding of one of the most intriguing celestial bodies in our solar system. Heliospheric particle trends unveiled. A comprehensive investigation by an extensive group of researchers from the Alpha Magnetic Spectrometer collaboration has led to significant insights regarding the behavior of energetic particles as they traverse the heliosphere. Over a period of 11 years, the team has meticulously analyzed data gathered by the Alpha Magnetic Spectrometer, an instrument operating aboard the International Space Station, to study the flux and interactions of various particles in space. Their work has culminated in the publication of 2 detailed studies in a prestigious scientific journal, each addressing different aspects of particle dynamics over the course of a single solar cycle. The research focused on understanding how the constant ebb and flow of solar activity, which follows a well-documented 11-year cycle, influences the charged particles that populate the heliosphere. Although the spectrometer has been continuously collecting data for over a decade, the scientists narrowed their analysis to one complete cycle in order to capture a coherent snapshot of how the Sun's behavior affects both particles emanating from the solar system and those arriving from outside as part of the galactic cosmic ray population. The variability in the heliospheric magnetic field, known to strengthen and weaken in line with the solar cycle, plays a crucial role in shaping the trajectories and interactions of these particles, and the instrument is specifically designed to measure their masses and energies with remarkable precision when they strike its sensors. In the course of their study, the researchers uncovered notable trends in the frequency and interaction patterns of particles recorded by the spectrometer during the selected solar cycle. One aspect of the investigation concentrated on antiprotons that are part of the galactic cosmic ray population. The team observed that the behavior of these antiprotons, including their interactions with other particles in the heliosphere, is significantly influenced by the fluctuating magnetic field. This interaction is manifested in the measurable charges of the particles, which provide a window into the complex interplay between magnetic forces and particle dynamics. The variations observed in the number of antiprotons and their collision patterns with the spectrometer's sensors offer valuable insights into how solar conditions modulate the presence and behavior of these subatomic particles. Parallel to this, the scientists conducted a separate analysis of the behavior of cosmic nuclei, examining the fluxes of several light elements such as helium, beryllium, lithium, boron, nitrogen, carbon, and oxygen. By tracking the temporal variations and changes in amplitude of these nuclei over the same solar cycle, the researchers were able to draw correlations between the observed flux differences and the underlying variations in the heliospheric environment. The study of these cosmic nuclei is particularly significant because it provides a broader understanding of how solar modulation influences not only individual particles like antiprotons but also a range of elements that are integral to the composition of cosmic rays. These nuclei, which originate from both solar and extragalactic sources, respond in a consistent manner to the dynamic forces exerted by the Sun's magnetic field, thus reinforcing the link between solar activity and cosmic particle behavior. The body of work produced by the collaboration is characterized by its rigorous approach to data analysis and its commitment to understanding the subtle, yet profound, influences of solar phenomena on cosmic particles. The ability to dissect the interactions of particles over an entire solar cycle has provided the scientific community with a more nuanced view of the mechanisms at play in the heliosphere. The findings contribute to a deeper understanding of solar modulation, a process by which the intensity and energy spectra of cosmic particles are altered by the fluctuating magnetic environment generated by the Sun. Such insights are crucial not only for advancing our knowledge of space physics but also for improving predictive models that can impact space weather forecasting and our understanding of cosmic radiation exposure for both spacecraft and future space explorers. By delving into the behavior of both antiprotons and a suite of cosmic nuclei, the researchers have opened new avenues for exploring how charged particles propagate through space under the influence of varying magnetic conditions. Their work underscores the intricate balance between solar forces and the myriad particles that travel across the vast expanses of the heliosphere. The detailed trends observed in the interactions and fluxes of these particles during a complete solar cycle illustrate the profound and often complex influence of solar activity on the fabric of our cosmic environment. This research not only enhances our understanding of the fundamental physics governing particle motion in space but also sets the stage for future explorations into the intricate relationships between the Sun, the heliosphere, and the broader cosmic landscape.
You just realized your business needed to hire someone yesterday. How can you find amazing candidates fast? Easy. Just use Indeed. Stop struggling to get your job post seen on other job sites. With Indeed sponsored jobs, your post jumps to the top of the page for your relevant candidates, so you can reach the people you want faster. According to Indeed data, sponsored jobs posted directly on Indeed have 45% more applications than non-sponsored jobs. Don't wait any longer. Speed up your hiring right now with Indeed. And listeners of this show will get a $75 sponsored job credit to get your jobs more visibility at Indeed.com/PODKATZ12. Just go to Indeed.com/PODKATZ12 right now and support our show by saying you heard about Indeed on this podcast. Terms and conditions apply. Hiring? Indeed is all you need.